Okay, so we're in journal 18 here, and we're going to be looking at a graph like you can see here. Looks like a U with arrows pointing up, and we have to find the domain and range. So let's actually find the range first. Remember, domain is representing the X values on this graph, and range is talking about the Y values. So when you look at the range, you're looking for the lowest Y value and the highest Y value. So when you look at this red line here, this red curve, it looks like the lowest Y value is at -3. So let me grab like a pink highlighter. So we're looking at -3, and it looks like it goes up, 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 up. Wait a minute. Notice how these arrows are pointing up. So that means that these curves are going to keep pointing up. So this is actually going from -3 to +infinity for Y. Positive infinity. So that means we're going from -3 to +infinity. So let me write my range out. Remember, we always write the lowest number to the highest number when we write an interval. And so parentheses on the infinities because we can never touch infinity. And -3 needs a bracket because, well, that's a solid line or a solid dot. So when I look at this curve here, next I'm going to find the domain. So that's saying, like, how far does this curve point to the left of the x-axis and how far right does this curve point? So in that case, I'm going to look at this curve and notice how there's an arrow pointing to the left. So that means that this curve keeps going to the left side of the x-axis. So it's going to actually -infinity. And then notice how this curve here goes to the right with an arrow. So it's going to keep on going to +infinity. So if it goes from -infinity to +infinity, that's all of the x values on this domain, on this x-axis. So we're going from -infinity to +infinity because that's the lowest x value that's going to go. That's the highest x value. And just as a quick reminder, yesterday we learned that if you get tired of writing -infinity and +infinity, you can also just use this symbol here. So another way you can represent this is all real numbers. So this R looks like an R with two lines in it, means all real numbers. It just means that it can be any number on that axis from -infinity to +infinity, which is exactly what this means. So if you get tired of writing this, just go ahead and write this all real number symbol. Okie dokie. So today's lesson, we're going to be talking about this U-shaped like curve. But first, we need to talk about x to the second power. So let's go ahead. Okay, so we've talked about x to the first power, right? And when you have x to the first power, it's just a line, a linear line. But now, when you have x squared, what does that look like, right? So one way we can figure this out is we can make a table and choose some x values to plug in, find some y's, because if you have x's and their corresponding y values, you have coordinate points, and then you can easily plot them on a graph to connect the dots to see the picture. So let's go ahead and plug in these values. So let me just remind ourselves here, anything that is squared means that you are taking that number and you are multiplying it twice. So here's what I mean. Notice how I have x -2 here. I'm going to plug it in for this x. So what that's going to look like is -2 squared, right? And just up here, -2 times -2 is +4. Because two numbers, when they're negative, they make a positive number, and 2 times 2 is 4. So this is +4. Now I'm going to do it with the next number here. I'm going to plug in -1. -1 squared is like -1 times -1, which is +1. 0 squared, 0 times 0 is 0. 2 squared is 4, because 2 times 2. Oh, sorry. I was looking at the other line here. My bad. 1 squared is like 1 times 1, which is 1. 2 squared is 4. All right, one of the observation I want you to notice here is that When you have a negative number and you're squaring it, ask yourself this: do you ever get a negative number back? When you take a negative number and plug it in, is it always going to be a positive number when it comes out, is what I'm asking. Yeah, it will be. The reason why is because if you square a negative number, you're going to have two negatives. And anytime you multiply by two negatives, you get a positive. And so that case here, all these numbers are positives, which tells me when I graph them, they probably will be in this region where y is positive. So let's go ahead and plug these in as our coordinate points. So remember, these here are our coordinate points. Let me see if I can shrink that down just a tiny bit. There we go. So I'm going to be graphing negative 2, 4. Negative 2 is here on the x-axis, x first, and then up 4. And then I have negative 1, 1. I have 0, 0 next, so that's going to be the origin. And then I have 1, 1. And then I have 2, 4. 2, 4 is going to be up here. And here's the thing. When you graph this, when you connect the dots, notice how you are actually going to curve, right? It kind of curves. It's not a straight line. Like, you don't want to try to draw a straight line because notice when you do, you miss the other point. So no straight lines here. So I'm going to get rid of that. And then I'm going to curve the other side. And I also noticed that this graph has sort of like a reflection. Let me do that a little bit better so that way they look more symmetrical. And so notice how there's like kind of it looks like a U shape. So this U shape is very iconic to x squared. So things that are x squared are what we call a quadratic equation. So quadratic equations are any function or any equations that have the highest power of 2. And when you graph them, they look like U-shape, but they are also called a parabola. So a U-shape, you can call that a parabola. And so when I look at this graph here, let's answer some of these questions. So one of the things that this kind of reminds me of is like the absolute value function where we were graphing v's, right? The v-shaped graph. And we called the middle part here the vertex. And so here's the thing, parabolas also have a middle part, and they also are called a vertex, right? And this vertex, you guys are probably going to already know, is a minimum, right? If I would ask you, is this a minimum or a max? It's probably a minimum because it's the lowest point on this curve. So we have a minimum for a vertex, and our vertex is sitting at 0, 0. Well, and that's because, you know, this here is a parent function. It is the original function, which we also call it parent function, for the quadratic equation. It just means that I haven't shifted this graph. Like I haven't added up any numbers into it or subtract any numbers into this function. It's just x squared. There's nothing fancy about this graph. All right, so looking at this here, you guys might also notice that there is this like symmetry, right? This symmetry kind of like this U shape, if I were to cut this in half, you would see that it would reflect. So let me cut this, that's really big. Let me see if I can make that less thicker. So if I were to cut this parabola in half, notice how this side of the parabola looks awfully identical to this side. It's like a mirror reflection. And so that mirror reflection is the axis of symmetry. Axes of symmetry are always written as an equation. So notice how this line here, how I cut it, it's a vertical line. And remember, vertical lines are x's, x equations. And this is because the vertical line hits the x-axis at, well, a particular x value. It hits it at 0, right? So in this case, this is x equals 0. And then our y-intercept, that's where the parabola crosses the y-axis, and the parabola crosses the y-axis at 0, 0. So this is going to be 0, 0. Remember, y-intercepts are when you cross the y-axis, but it's a coordinate point. And so that point right there is 0, 0. The domain here, domain is talking about, you know, the x values, how far it points to the left, how far it points to the right. But here's the thing. Parabolas keep on extending, and notice how there's an arrow to the left of the graph. So it's going to keep wanting to extend more left. So it's going to negative infinity. And then on the other side here, there's an arrow to the right. So it's going to keep wanting to extend to positive infinity. So it's going from negative infinity to positive infinity. Or you can say, or write it as all real numbers. In fact, for all domains for a parabola or for a quadratic equation, there will always be all real numbers. So let me just put a little note here. So all quadratic equations have a domain that is all real numbers. That's just because it's always going to be pointing left, it's always going to be pointing right with these arrows, and that causes it to extend to its extreme values, which is the infinities. So last thing here, the range. Now the range is not the same, okay? It's not going to be all real numbers because it's this vertex here. Notice how the vertex is the minimum value here. So that's the lowest y value, which is at 0, right? So the lowest y value here is at 0. Excuse me, that should be a bracket because that's a closed circle. And then here's the thing. The other side of the parabola is keeps on extending with arrows. It keeps going up. So that means I'm going to positive infinity. And so with the range, you're going to actually determine that by looking at the vertex and then where the arrows are pointing up or sometimes down. So let's practice this skill in the next slide here. So what I'm going to do is give you guys a bunch of quadratic equations, but I'm going to add more shifts or add more numbers to the equation. So that way you guys can see what happens when you add certain numbers and certain signs to the quadratic equation. How does that shift the graph? Okay, so here's a table where I have 5 different types of quadratic equation. Notice how their highest power here are 2. The only difference is that I have some parentheses here with numbers inside the parentheses and numbers outside the parentheses. And so what we're going to do is graph them, figure out their shifts, and then, yeah, that's pretty much it. We're going to graph them, find their shifts. Now, if you were in class, we did this where we did one together, and then I assigned you one, and then we looked at the end, we looked at all of each other's graphs and then filled out this table. Now, for us, we're not going to look at the graphing calculator. We're just going to, I'm just going to explain to you what happens when you have these numbers in here. So it's very similar to the types of shifting that you guys saw when you had absolute value equations. So this is your generic type of absolute value. We talked about when there was a minus sign inside, you are shifting either left or right. But if it's a minus sign, you're going to be shifting, see if I can write this. So if it's a minus sign on the inside, you're going to be shifting right. If it's a positive sign on the inside, you're going to be shifting left. Whereas this plus sign here on the outside, notice how this is outside of the absolute value, that's going to either be telling you your vertical shift. So if it's a positive, you're going to go up. If it's a negative, you're going to go down. And so that's pretty much the same here. The only thing is we don't have absolute value. We have parentheses. So anytime you have a minus sign, you're going to be going right on the inside. So when I graph this, real quick. Remember that first graph that we had for the parabola? It sat on the origin, right? Well, this time it's going to be shifting right 2 units, right? 2 units. So this is going to be shifting right 2 units. And then I would plot and then draw my U. So I'm just doing a very rough sketch. So this shifted right 2 because it's a minus 2 on the inside. Now there's nothing out here, so there's no shifting that's going up or down. And so now my vertex is sitting at, well, remember x is first, then y's. So it's sitting at 0. Oh, sorry, not 0. 2, 0, because we didn't shift the y, so it's still sitting on that, on the x-axis. So y here is 0. All right, but then the opposite, if you have a plus 2 on the inside, you're going to be shifting left. So this is going to be left 2. So let's see what that would look like on the graph. So left is going to be this way, and now it's negative 2, right, if you shift that way. And so in this case, if I were to draw parabola there, it's just going to sit on top of that x equals negative 2. And so my vertex here would be negative 2, 0. And then my next graph here, let me just prepare my graph. I notice it's a minus 2, so that means I'm going right. But it's a plus 1 on the outside, so that means I'm going up. So this is going to be right 2, up 1. So that's going to be right here, and then it's going to open up with a U. So this is right 2, up 1, and so my vertex here is at 2, 1. And then in my next one here, I have a right, because it's minus, 2. Oh, my bad. Let's change this so this is a little bit different. Let's make this I forgot to change the slide. Let's make this a minus so we can make it more interesting. So what if this was a minus sign instead? And so now I can say this is going down. So this is going to be right 2, down 1. So 2 is here, down 1 is at negative 1. If I were to plot there and then open up my U, there we go. So my vertex is at 2, negative 1. And so I went right 2 units, down 1 unit. So whenever you have a minus sign on the outside, you're going down. And then this one here looks very similar to that third equation. The only thing is there a minus sign on the outside. And so if you were to graph this, what it does is it flips the U upside down. So notice how all of these outside the parentheses, they're positive, right? Because there's not a negative sign in front. Well, if you have a negative sign, it flips it. And the reason why is that, remember when we were graphing our first x squared and you squared every number and then it was a positive y value? All the y values were positive because you squared it. So anytime you square a number, you get a positive number, and so all the y values were positive. Well, if you stick a negative in front of that positive number, obviously it's going to turn negative and want to flip it upside down. So let's go ahead and graph it. So this is still the same. It's still going to go right 2 plus 1 on the outside means up. So right 2, up 1, and I plot my vertex, but this time it's going to point down because there is a negative sign here. So my vertex in this case is still that 2, 1, but it's going to be pointing down. So this is still right 2, up 1. Okay, so I hope this gives you kind of an overview of each types of graph and each type of shift, but it's kind of hard to, like, when you're given a situation where you have to figure out the graph, that you want to go back and look at this table. We need a more organized way of figuring out all these different shifts. So in the next slide here, let's kind of put everything together so that way when you see a graph or a quadratic equation that has these parentheses, you know how to shift the graph and what the graph would look like. All right, so here is my quadratic equation. Here, notice the x squared. So this is a very generic template. Now this part is very important because you need to know how to shift a quadratic equation that is in vertex form. Vertex form just means that you have these parentheses here, and vertex form for a quadratic is so nice when you want to plot the vertex really quickly, okay? That's the advantage when it is in vertex form, is that you can plot the vertex really quickly by the shifts. So let's begin. We saw that inside the parentheses tells you your horizontal shift. So if you have a minus sign on the inside, we notice that it was shifting right. If you have a positive sign, you're going to be shifting left, the opposite direction. So this is kind of weird. So inside the parentheses, you got to think opposite. When there's a minus sign, you're going right. If it's a positive sign, you're going left. Whereas the outside here, if you have this K plus K on the outside, a positive does mean up, a negative means down. The outside of the parentheses tells you your vertical shift. And then this A that sits right next to the X, well, that technically you can use as your slope, technically, so that's why I'm going to put parentheses around it. This will just help you plot more points on the graph. Now, that being said, I just want to mention about the slope. You don't want to use the slope more than once. And I'll explain this when we do an example together. So that's why I have these quotation marks around it. So this formula here will help you, make your shift so that way you can graph the vertex, and so then you could graph your parabola. All right, let's do an example problem together. Okay, so here's an example of a quadratic equation. Notice the highest power here is 2, right? And so what I'm going to do first is always determine what that shift is. And so in this case, I notice that there is a +1 on the inside. So that means I'm going right 1. And then there is a +3 on the outside. So I'm going to go up 3. So if I go right 1, up 3, that's right here for my vertex. And so my vertex coordinate is 1, 3. Here's the thing you never want to do. Don't ever distribute this inside the parentheses, because please excuse my dear Aunt Sally, parentheses first, then exponent, and then multiplication. So that's why you don't want to distribute quite yet. All right, so there's my vertex. My minimum and maximum I won't know until I have more points on the graph. So just like when you're graphing, the V's, those absolute value functions, you need 3 points to graph a V, or an absolute value function. Parabolas will also need 3 points, 1 for the vertex and then 2 on the side. And to do that, we use you could probably guess it, it's the slope. So this slope here is a 2. It's a 2, right? And so my slope, I can write 2 over 1. Here is the most important thing. If you decide to use this as your slope, your run will always be 1. Let me put that to the side here since it is kind of important. So if you decide to use this trick where you're using the slope, you must remember, so for quadratics, the slope run is always 1. Kind of rhymes, right? The slope's run is always 1. So this one's okay because the slope here is a 1. So when I graph it, I'm going to go up 2, because that's rise, up 2 over 1. So you're going to go from the vertex and then use your slope, and then I'm going to plot. So be right here. And then here's the thing, I'm going to graph and make a curve. You want to make a curve like that, so like a U. And then remember, the quadratic equation has a line of symmetry, so you want to go up 1 again, but now to the left, just like absolute value functions. So I'm going to go that way. And so there we have it, 3 points on the graph. And so you guys are probably asking, well, what if the run is not 1? What do we do? Well, I will explain that in some of the homework problems that we're going to be doing. So watch out for that video if you need more help. So the next video, I'll show you cases where that is not always the case. So let's take a look at the vertex here. This vertex is sitting at the lowest point of the parabola, so it's a minimum. The axis of symmetry, well, if you cut this in half, right? The line of symmetry here, remember vertical lines are x equations because they, intercept the x-axis, and this one intercepts it at 1. I also like to mention, if you guys are starting to notice this pattern, is that the axis of symmetry, that x value is always the same x value as your vertex. I hope that highlights a few things here. It's always your x value for your vertex. The y-intercept here, we can see the y-intercept here is at 5. So this is at 0, 5. The domain here is going to be, well, all parabolas. Notice how it points left and right. It's going to go to negative infinity and positive infinity. So this is all real numbers. Or negative infinity to positive infinity if you want to write that interval instead. The range here is going to be the lowest y value, which is at 3, and it's pointing up, so it's going from 3 to positive infinity. And I need a bracket on the 3. Also, I like to mention, notice how the y value here, you know, the 3, right, is also the y value on the vertex. Just thought I'd mention that. It's just because the vertex always shows them the minimum value, or sometimes it's the maximum value. Okay, so in the next video that I will upload, I'm going to show you guys how to do the homework problems on page 1. So if you need help with your homework, please watch that video. I want you guys to understand how to do these practice problems.